we are going to use rectangular cross section, there will be lot of difficulty in calculations. Okay, I think everyone can see my screen, yes or no? Okay. Here we have to design a Gib and Cotter joint. We have to design a Gib and Cotter joint. We have to design a Gib and Cotter joint. We have to design a Gib and Cotter joint, which is carrying a maximum load of 35 kilonewtons. Is carrying a maximum load of 35 kilonewtons. Assume that Gib and Cotter end rod are of same material, having allowable stresses. One is normal stress is equal to 20 megapascal, shear stress is equal to 15 megapascal, and also just a minute. Okay. Here we have to design a Gib and Cotter joint, which has to carry a load of 35 kilonewtons. 35 kilonewtons. Assume that Gib and Cotter and rod are made up of same material, which is having the allowable stresses as follows. See, from the question, it was given that P is equal to 35 kilonewtons. P is nothing but load, which is equal to 35 kilonewtons. 35 kilonewtons is nothing but 35 into 10 to the power of 3 newtons. And also here only it was given that normal stress is given as 20 megapascal. 20 megapascal is nothing but 20 into 10 20 megapascal is nothing but 20 newton per millimeter square. Similarly, shear stress is equal to 15 megapascal, which is 15 newton per millimeter square, and crushing is 15 newton per millimeter square. Okay, this has been provided in the question. Here we have to design three components. Here we have to design three components. The first and the main, we are going to design a shaft, or in this case we are writing it as a rod. Okay, but in this special case, as it is a bar, it is a rectangular cross section, we will be representing it as bar. And the second component is we will be designing a Gib. Here it is a Gib. Second component is Gib. And the third component is we have to design a strap. This is a strap. Strap is nothing but it is a sleeve in the previous case. Okay, in the previous case or in the previous diagrams, it is a sleeve, but sleeve is a circular cross section, whereas strap is rectangular cross section or square cross section. You have to remember that this is the only difference. And the fourth one it is we have to design cotter. These are four components that you have to design for a particular this type of joint. Okay, if you see in the side view, this is the side view. This is the side view. In the side view, you can see it is made up of a square cross section. It is made up of a square cross section. Observe that. Okay, whereas in the front view it is like a rectangular cross section. That means cylinder or anything will be in a rectangular cross section when you are seeing it from the front view. Okay, anyway, let us start designing these four components. First one is shaft, if not rod, if not bar. Actually in this case it is bar. Okay, the second one it is gib, third one it is strap, and fourth one it is cotter. These four are the components that we have to design. Okay, see, before going to our topic, let us see what is actually a gib and cotter joint. What is actually a gib and cotter joint? Okay, you can find that in YouTube also. Find that in YouTube also. Okay, just type Gib and Cotter joint so that you will be finding an animation. This is how Gib and Cotter joint look likes. This is how Gib and Cotter joint look likes. Just see the animation, how it look likes. You can see that. These are the parts of Gib and Cotter joint. I have already shown you that. So just wait for a while. I am getting some internet connection error. This is gib. This is cotter pin. Gib will be inserted inside the cotter hole and it will be dragged towards one of the corners. Dragged towards one of the corners. This is how. Then the cotter pin will be inserted. Then the cotter pin will be inserted. This is our Gib and Cotter joint in the front view. If you see in the side view, this is full sectional view. Half sectional front view. This is. Just one more time I am replaying this video. You can see I end is nothing but we have written as strap end. Gib we have written as gib. Pin we have written as cotter pin. This is Gib and Cotter joint. Okay. Anyway, you can see this video in any number of times in your YouTube. This is just a public channel only. You can see that in your YouTube channel. Okay. Now let us try to solve this problem. Okay. See, in any of the joints problem, first step will be design of shaft or design of rod or design of bar. In this case, it is bar. Okay, here first one is nothing but here side of square bar. Side of square bar. In the previous joints, we have determined it as diameter of rod. Okay, because it is a circular cross section. As it is a square cross section, I am writing it as psi. Okay, here the formula will be P is equal to x square into sigma. In the previous case, it is P is equal to pi by 4 d square into sigma, where pi by 4 d square is nothing. Pi by 4 d square is nothing but area of cross section of the circle. Here, area of cross section of circle square is x square. So I have represented as x square. Okay, here P is equal to 35 kilonewton, which is being provided in the question. Sigma value is equal to 20 Newton per millimeter square. That is also being provided in the question. Just x square is the value you have to write. Thereby, find out. Thereby, x square is equal to P is 35 into 10 to the power of 3 by sigma value. Sigma value is nothing but 20 kilonewtons. Sigma value is nothing but 20 Newton per millimeter square, thereby 20. Can anybody give me the answer for x value? Answer for x value is equal to 42 millimeters. 42 millimeters. Answer for x value is equal to 42 millimeters. Is my voice loud and clear? Yes or no? Is my voice loud and clear?
Yes, sir.
Okay. Now, by design considerations, by design considerations, we will be determining other values also. After finding x value, we will be determining other values also. Okay, by design considerations such as b1 is equal to x. Okay, these are by design considerations. If not by design data book, we are going to determine these values. Okay, that is x1 is equal to b, which is equal to 42 millimeters. Similarly, t is equal to b1 by 4. T is equal to b1 by 4, that is 12 millimeters. T2 is equal to T4 is equal to 12 millimeters. These are our values. These are our values from design data book. Design data book. But design data book is not being allowed into our examination hall, so that these values should be remembered by you. You have to remember these values. That is b1 is equal to x is the value that you have to remember. T is equal to b1 by 4. T2 is equal to t2 by 4. T2 by 4. T2 is equal to T2 is equal to T4 is equal to 12 millimeters. That is what you have to remember. Okay, T2 is equal to T4 is equal to T. If you want, you can see what are the variables from this over here. If you want, see T is over here and B1 is over here, over here. As this is X, thereby this will be also X. From the figure you can find it over that. Okay, and T is over here. Similarly, T2 and T4. T2 is over here, and also T4 will be, you can find T4 over here, somewhere over here. Okay, and we have found out all the values that is being asked as per the design of our particular joint. That is b1 value we have found out, t value we have found out, t2 value we have found out, and t4 value we have found out. Okay, this is from the first formula. Anyway, I have given these all values and how to find all values in design procedure of this particular problem. And the second step is width of Gib and Cotter. Width of Gib and Cotter. If you want, you can do this problem separately with respect to B1 and B. If not, you can directly consider the total width of Gib and Cotter as B, and you can directly go for your answer. According to your comfort, you can go for that. But I will consider total width as B. In that, I will consider share of B1 and B2 separately as per design data book. If you want, you can go with B1 and B2 separately. That is, formula is B is equal to 2B T into shear stress. Okay, if you want to find out, if you want to consider B1, you have to write this formula with respect to P is equal to 2B1T into sigma separately, and also P is equal to 2BT into sigma separately. These two are the formulas you have to write combinedly. That should be equated to this P value. Okay, see, instead of these things, what I will do is, I will just find out the value. I will just find out the value, and then I will add it to the, I will find B1 value, B2 value as per the ratios that is being provided in the design data book. That is, first let us try to find. Here P value is being provided. T value, I think we have found out from the formulas. Sigma value is also we have found out. Thereby, here B is equal to P by 2T shear stress. Thereby, B is equal to P is nothing but, if I am not wrong, it is 35 kilonewton. Thereby, 35 into 10 to the power of 3 by 2 into P value. Can anybody tell me what is the value for T? It is 12 millimeters, and also shear stress is 15 megapascal, nothing but 15 Newton per millimeter square. If you find out this, if you calculate this value, B will be equal to 100 millimeters. Okay, see, I have found out combined width of Gib and Cotter, but I have to find out width of Gib and Cotter separately. Thereby, from the design data book, B1, sorry, it is small b1, B1 is equal to 0.55 into capital B. B is equal to 0.45 into capital B. That is 0.55 into 100, which is equal to 55 millimeter. 55 millimeter. This is equal to B1, width of Gib. Here in the figure, it is over here, width of Gib. Similarly, 0.45 into 100, this is equal to 45 millimeter, which is B value. This is this one, width of Cotter. Okay, we have found out width of the Gib and width of the Cotter separately. If you want, you can find out by using this formula also. Okay, separately you can construct for B1, you can go for B1 and B, and you can find out your answers. Okay, you can find out your answers. This is our width of Gib and Cotter. Okay, let us go and find the other values also as per the design procedure. The third one is, see here, we have found out T2, we have found out B1, B, capital B, T and B1. Okay, the thing is that we have to find out now T1 value. T1 value is nothing but thickness of the strap. This one, thickness of the strap, this thickness we have to find out. That is thickness of strap. Okay, we have a formula, that is P is equal to 2 into XT1 minus T1 into T into sigma. Okay, this is something like, see, in the previous case, I have drawn a concentric circle, something like this. I have drawn a concentric circle, and there is a hole for this concentric circle. Okay, I have formulated some formula by using this concentric circle. Similarly, now by using this formula, I have to formulate that. Okay, this is nothing but X. Okay, and this is nothing but T1. Okay, and this is nothing but here. This is nothing but T1. Sorry, this is nothing but T1. This is nothing but a T. This is nothing but a T. Okay, now by using this formula, you have to, by using this form, you have to find out a thickness of this tab. Okay, here the area of cross section is x into T1. That means you will be finding only area of cross section of this category. Okay, on this one, only this category, which I am marking with yellow color. In this, you have to take out this one. Here I have written T value in the wrong way. You have to eliminate this one. This is your T. Thickness of the slot only. Here, if you see here, only quarter is being inserted. That means nothing but thickness of the slot. Thickness of the slot. Only this one. Only this one. You have to eliminate this area of cross section and this area of cross section. This area of cross section and this area of cross section should be eliminated. Thereby it is x into T1, you will be getting whole total ring minus T1 into T. Okay, as the force is perpendicular in this direction, it will be coming under shear force. Thereby shear force is equal to, this is the form. Now, in this particular formula, we have P value. We don't have T1 value, we have T value, even we have X value, even we have sigma value. The value we don't have is T1. Just we can find out T1 value from this formula, that is P is equal to, see here finding out T1 value is a bit complicated. Okay, we can write it in the simple form also, that is T1 is equal to, you can take T1 common over here, P by 2 sigma multiplied with x minus t. Just substitute the values, thereby T1 is equal to P value. P value is nothing but it is 35 into 10 to the power of 3 by 2 into sigma value. Sigma value is being given in the question, that is 20 megapascal into x. X value we have already found out, that is 42 minus it is T value. T value also we have already found out, that is 12. Just calculate this, you will be getting T1 value, that is nothing but 30 millimeters. T1 value is 30 millimeters. And see here, if you want to verify, you can verify. Okay, if you want to verify, you can verify. But I am not going to verify my answer, because definitely my answer is not going to satisfy with the values. Okay, let us check. Is there any possibility or not? Okay, verification, only one verification, that is over here, that is verification is by using the crushing stress. In this figure you have eliminated other component, you have eliminated slot component. Now in this figure only we are just going to consider only slot composition, that is P is equal to area of this slot. Here area of this slot is nothing but T1 into T for one side. As it is two sides, it is 2 into T1 into T. Thereby 2 into T1 into T. As we are considering the crushing part, it will be sigma C. Okay, let me drag this figure over here so that figure will be available for us at any time. Now, just substitute the values. We have P value, we have T1 value, we have T value. Okay, we have even sigma C value only. As it is verification, we have to find out sigma C value, that is sigma C is equal to P by 2 T1 T, which is P is equal to, if I am not wrong, P is equal to 35 into 10 to the power of 3 by 2, T1 is 30, T is 42. Okay, if you verify your answer, sigma C is equal to 48.6 Newton per millimeter square. If you see in the question, sigma C is a bit more than the value that we got as per the question. Okay, a bit less than only, that is in the corner. 48.6 is nothing but 49, very near value. Okay, anyway, no problem with the whatever the value is, no problem, we got less than the value that is being provided in the question. Okay, but in some cases you may not get that, don't worry about that, just leave it over there and proceed with your answer. Okay, anyway, it is less than 15 Newton per millimeter square, which is being provided in the question, provided in question, provided in question. Hence, our design is safe. Our design is safe. Our design is safe. Hence, our design is safe. Okay, verification is completed. Next, step number 4. Okay, you can even skip this verification also. Okay, here I am writing. If you want, you can skip this verification also. No need of this verification. If you want, you can go for verification also. Okay, anyway, additional points will add good marks to our presentation. Okay, that is your wish. You can, if you want good marks, you can go for verification. If you want to skip it, lack of time, you can skip it. Okay, the next one is length of rod, length of the rod. Okay, length of the rod. Okay, length of the rod is nothing but here, that is we are going to find out length of the rod as this one here, L2, from here to here. What is the length of the rod? That is we are going to find out. That is what we are going to find out here, from here to here, here, length of the rod. This is what we are going to find out. Length of the rod L2. See, here we have found out E1, T1. T1 we have found out, T1 we have found out, X value we have already found out. Okay, now if we are we are going to find out L2 value. Okay, we are going to find out L2 value. Okay, that is, here we have a formula, P is equal to 2L1 X shear stress. L1 X shear stress. Okay, as it is as the value over here is parallel to the axis, thereby we will be considering shear stress only. Okay, we will be considering shear stress only. In this formula, we know what is P value, we know what is X value, we know what is shear stress value. The known, only unknown value is L1. Thereby, L1 is equal to P by 2x shear stress. 2x shear stress. Thereby, here P is nothing but 35 into 10 to the power of 3 by 2 into X value. X value is nothing but, we have already found out that X value, that is 42 millimeters. And shear stress is already provided in the question, that is 15 millimeters. Thereby, L1 is equal to 28 millimeters. L1 is equal to 28 millimeters. Okay, here we have to find out only a limited parameters. One is L4, the other one is L3, the last one is L1. Only these parameters we have to find out. Okay, only these parameters we have to find out. Okay, let us find out. I think we have found out L2 value. We have found out L2 value. Now, sorry, we have found out L1 value only. We have found out L1 value only. L2 value, L3 value, and L4 value are the parameters we have to find out. Let us find L2 now. Let us find L2 now. As we have found out L1 now, let us find L2 now. Thereby length, that is of the rod on the other side. See, length of the rod L1 is nothing but, this is also length of the rod and this is also length of the rod. Okay, on one side we have found out length of the rod L1, the other side we are going to find out length of the rod L2. Okay, here also you will be getting the same formula but a bit different, that is P is equal to, as L2 is undergoing double shear. Okay, in the previous case it is undergoing only single shear, thereby we have taken only 2 into L2. As it is double shear, we have to consider 2 into 2L2 T1 into shear stress. 2L2 T1 into shear stress, as it is undergoing double shear. As it is undergoing double shear. Here P is, we already know. L2 we already know. Sorry, L2 is the value we have to find out. T1 we already know. Sigma value we have already known. Thereby just find out your answer. Find out your answer, that is L2 is equal to P by 4 into T1 sigma. That is, P is nothing but 35 into 10 to the power of 3 by 4 into T1 value is provided as 30 millimeters. It is, we have already found out as 30 millimeters, into shear stress is 15. Shear stress is 15. If you find out, you will be getting L2 value is also equal to 28 millimeters. In most of the cases, L1 and L2 will be equal. If not nearly equal, will be equal, if not nearly equal. Okay. And the last and final step is that length, sorry, the last and the final step is that length L3. Okay, we have found out L1, we have found out L2, and we have to find out L3 and also L4. Let us find out L3 first. Let us find out L3 first. Let us find out L3 first. Here, for finding out L3 value, we don't have any derivation, just it is an design data book value. That is, I will be changing the color. Length, sixth one is length of strap, that is L3. Here it is L3, from here to here, from here to here, length of the strap L3. Okay, L3 is equal to 2 by 3 into X. 2 by 3 into X. Okay, that is 2 by 3 into X is nothing but 42 millimeters, which will be giving 28 millimeters answer. Which will be giving 28 millimeters answer. Okay, here we have found out almost all the values. If you want to find out one more value, you can find out that is length of cotter. Length of cotter, we already know the formula for this. Length of cotter, L is equal to 4 into diameter of the shaft. Okay, here in this case it is X, 4 into X, which is 4 into 42, which will be 168 millimeters. 168 millimeters. Okay, this is how we find out this is how we design Gib and Cotter joint. This is how we design Gib and Cotter joint. Gib and Cotter joint. Okay, here there are only 6 steps to be followed in order to find out, or in order to design Gib and Cotter. See, here we have found out all the parameters of the shaft or rod. Okay, we have found out all the parameters that are used for Gib. We have found out all the parameters for strap and also all the parameters for Cotter. Okay, we have found out all the parameters for these 4 components, so that our design procedure has been completed.